Last up for this block, longtime friends, new time engagement, Damien Garros, and what he's doing with OpsMill. Damien, take it away.
Thanks. Thanks, everyone. Very happy to be here. So we're going to talk about how we can revisit, some of the concepts around infrastructure as code and network source of truth, and most importantly, actually, why we should revisit them. So to tell you a bit about me, so I'm the co-founder and CEO of OpsMill. We're a new player in the infrastructure automation space, and specifically our focus is around bringing new perspective to the network source of truth aspect. So I've been involved in infrastructure automation, observability for more than 10 years. The last 5 years, I will say my main focus was really on network source of truth. And what I'm going to share today is really all of that knowledge that that perspective that I gathered over the years that ultimately led to what we're doing at OpsMill. Just so you know that before actually starting this project, I was part of Network to Code. I was leading the technical architecture team, and I was part of the team that started the Notobot project. So when I saw that so many of you were actually using Notobot in the project, in the survey, I was very happy. It's really cool. So what we're going to talk about is first, I want to make sure we have a shared vision of what is the state of industry. So I'll share my perspective, and specifically around the network source of truth. Then I'll share some of my analysis of what are the pitfalls or the issue that we have, the gaps right now. Then we'll talk about what we can actually improve. And then I didn't want to make that a product presentation, but at the end, I just want to show you give you a sneak peek of what we've been working on. And again, all of that is more to start the discussion. I want to say this presentation, I'm kind of assuming, and it's really designed for automation practitioner. It's so rare to have so many people that actually have been practicing automation in the same room that for once I can say I'm not going to cover the basics topic. And I'm sorry if you don't know of them, probably go learn them and then rewatch this talk. But I'm kind of assuming you already know what is the source of truth, what is version control, the importance of that. And so I'm going to go straight to the important part. So what is the current state of the industry? What we've seen is everyone has been successful with automation, has built what we call an infrastructure management platform. There's a lot of building blocks for observability, deployments, and in the middle, we have the source of truth that captures the intent of the network. What we're seeing is the market is kind of fragmented right now. There's really two types of deployment that I'll cover. It's either you decide to put all of your states and your intent in a database, we'll call that a database-first approach, or you go more the Git or the infrastructure as code approach where everything will be in Git. And if you summarize the last 5 years of my life, is how can I get both at the same time? And I've done dozens of projects that are database first and Git first, and every single time we came back to how can we actually get both? And that's been the issue that has been really driving me for all this time. So if you look at the database first, yes, there is a database that can usually be either Netbox, Notobot. More often than not, we actually found that very successful organizations, they've been building their own database, mainly because they want to have full extensibility of the schema, and we'll see throughout the presentation how important that is. But then there's more than a database. There's usually also one, often multiple, side projects that are in Git that have configuration template, scripts that we're using to deploy, touch the devices. So seeing that it's just the database, it's not representing the full solution. And then those systems, because they usually have an API, they have a query engine, they have all of that, they also have some integration with the rest of the infrastructure, either integrated through the observability stack, through the CMDB, all of those different systems. Now, the other approach is the infrastructure as code approach, where everything will be in Git. We're going to put all the data in Git, in YAML files, everything will be in Git, and then we'll be able to fully leverage the CI/CD approach and the full immutable infrastructure concept that we're getting from infrastructure as code. I will say the cloud guys, I will say 95% are probably doing it this way. In our world, I've seen, again, a lot of really big projects doing it this way, and I've seen the other way. Now, let me ask you, how many of you have actually deployed either of those solutions or are actually using those solutions? So yeah, I will expect a fair number of people. And I will say first, congratulations, because it's first a big achievement. And I think I've been there, and usually when you deploy those solutions, you feel like you solved it all. And I've been there, and you talk about it. Now, personally, after working with a lot of different companies, what I learned is that we're usually going through like kind of something that looks like the hype cycle. After the excitement, we actually realize that it's not that perfect. Yes, it's so much better than what we had previously, but in my perspective, there's still a lot of work ahead of us. And that's really why I think we should revisit those concepts, and I think why we need to talk more about what is ahead of us. Because, again, we're not fully achieving the goal, and the last 5 years of my life have been, how can I get both? And I haven't seen anyone really getting both today. So to talk about the limitation, to make sure we have a shared understanding, the issue we are seeing with the database approach is that first, there's no version control. People realize that's a big problem when you want to make big changes, hard changes. It tends to be complicated to maintain. Like I've seen organizations sometimes taking up to 6 months just to be able to upgrade to the latest version because the APIs are changing, the schema is changing, and there's the coordination so all of those projects that's really hard to manage. There's often the complexity about how do we manage the schema, especially if you're using like existing solution like Notebot or Netbox that comes with their own schema, and there's always constraint on how can we actually extend the schema. That's why we've seen so many people building their own from the ground up, accepting that it will cost them even more resources just to be able to be in charge of charging the schema. And then one issue we're seeing also is that those solutions, because we don't have version control, they tend to have like a partial integration with the CI/CD pipeline. And usually that kind of hurts when we actually try to use those concepts, but not all the version has the concept of version control. On the Git side, the issue is that there's no API. The bigger your system is, the more data you have to manage in text files. There's no schema. You tend to have a lot of duplicates because you can store a lot of data in Git, but the more relational is your data, the harder it gets. And then also the pipeline, when we actually can use all of those pipelines, I've seen organizations sometimes taking up to an hour just to shut down an interface. Because in this concept, if everything is in Git, it means to shut down an interface, you need to do a branch, you need to do a pull request, you have to go through the entire CI pipeline that usually will run on your entire infrastructure. Then you need to exprove, you need to merge, and then you need to do that again and deploy. And those systems tend to have those it's really good for very hard and complex changes, but it tends to be hard for the very small changes. Now, if we look at all the capabilities that I will be looking for the right source of truth and automation platform, like having great user experience, being able to have external integration, having a schema, a query engine, having the ability to do peer review, to manage complex changes, what we're actually seeing when you put that to those different solutions is that they have almost opposite capabilities. And my analysis is that we optimize the database first for really the small day-to-day changes, and the Git one for the complex changes. And I think to the question of this conference of why have we not seen more adoption of automation, I think it is a big part of the problem, is that the tool that we have are optimized to a part of their job, and we're not able to fully support us to the entire part of what we actually need to achieve. So before going into the analysis, I'd love to talk on a specific point that I think is super important when we talk about source of truth. It's the importance of having a schema and the importance of having a query engine. So I'd just like to take you through a bit down memory lane. In my perspective, in 2016, when Netbox came out, and they brought the DCIM, the IPAM, and circuit management together in the same solution, I think there was really a breakthrough in our industry. Many people started to realize how helpful, valuable It was to have all of those different information in the same database, in the same schema, and to be able to make query that will understand how circuits relate to an interface, relate to an IP, relate to a specific device. And then in 2020, when Netbox introduced the plugins, we started seeing even more data now that will fit into the solution. Like we had the circuit maintenance, we had what we call the device lifecycle, we had BG-free information and security information. And the more data we'll put in the same database, the more value we will get out of it. And then in 2021, when GraphQL started to be adopted across the industry, then it became even easier to extract all of this data, this very interconnected data, and being able to consume that from outside. And I think it's very important to, because today, when we're doing the Git approach, for example, we're kind of giving up all of that. We don't have the schema, we don't have the database, we don't have the relationship. Now, personally, I call that the infrastructure graph. This idea that we put all of those different models and objects and data in a single database, and we capture the relationship between them. What's interesting is we can capture the technical information, but we can also put like the non-technical information, like the design information, the service, the business information. And the more interconnected they are, the more value we get out of those data. We have automatic documentation. We're able to reduce the errors and the inconsistency in the data. It's so much easier to actually generate the configurations when you have everything in a single place and you have a proper query engine to collect everything. There's a lot of value when you start connecting those systems to the observability platform. And then it's so helpful when you actually need to build tools that will troubleshoot the need to understand what is the expected state. Now, there's something that I feel like we're not talking enough about in our industry, is that we're actually not the only one that realize that putting everything into a single database, having these global models, that will bring a lot of value. It turned out that other industry, they actually call that a knowledge graph. And it's a concept that when you put everything in a single place and you have a great query engine, then you will find more value out of your data. This concept has been applied through every industry, retails, pharma, cybersecurity. Like in many ways, what we're doing is really not new and unique. And we'll see through the presentation, but I think there's a lot of things we can learn from what the other industry are doing on how we can manage those big database with those large schema and large query engine. So we'll get back to that. So when we started OpsMill, and again, after 5 years having everyone say, hey, can I get database and Git together? It really felt like it was time to go back to the drawing board and trying to see, like, why can't we get both? And so that's kind of what we did. And when we get back to the drawing board, we really started at the very high level analysis. And in a very, very simple term, what is running an infrastructure? What does that mean? I will say the mission that we have to carry. The first one is we have to support the business by deploying new services or new infrastructure. And we have to make sure that everything's run, and we have to keep the lights on. If we go a little bit lower, what does that mean? So we need to manage two types of changes, standardized changes, non-standard changes, and we need to do some troubleshooting. Going even deeper, what is a standardized change? If we need to add a VLAN, if we need to add a service, if we need to drain a device. Usually those tasks, you want them to be self-service. You want them to be completely automated. You want users to go and be able to decide what they want to do because you understand them. You can pre-validate them. You can have a lot of unit tests. And for that, you need to have a user forum, you need to have APIs, you need to have all of that. Now, if we take the non-standardized changes, it's the complete opposite. It's the one you cannot really automate because they don't happen often enough. You don't really understand them. You don't want to have an API because, again, you don't know what the API will look like. So for those, you need to have an isolated environment. You want to have peer review. You want to have continuous integration. And you can see that there's definitely a parallel with the capability of the database first and the Git first that I showed you earlier. If you look at it, we've been optimizing the database first system for the standardized changes, and we've been optimizing the Git first for the non-standardized changes. And again, there is no solution today, to my knowledge, that can actually do both. I just like to say, because before someone come in and mention that I was able to put a UI and an API in a query engine in Git, I think with enough time and resources, yes, you can do it. You could do everything. I've seen for smaller data sets, you could use Git as your database. I know some systems did it. But I think it's just something that is not sustainable at scale for in terms of performance and just the amount of efforts they will do. So that's just kind of an assumption that has been built in. Now, if you look at the business requirements, again, having a UI that helps to have a better user experience, that also means that more people in organizations will be able to use the tool that we're building. And the APIs means we'll be able to integrate with the other systems. We'll have programmatic access. We already talked about the importance of the schema and the query engine. The version control helps reduces the risk, having the traceability, the peer review. And then there's this concept that I'll cover a bit later that we call the unified storage. We think is super important and helps to have those atomic changes. And it is also very important to reduce the risk. So now that we covered all of that, what can we do to improve all of it? So I'd like to cover 4 points. And we may skip the last one if we're running out of time, but it's such a large topic that probably could be a topic on its own. So if Scott starts to wave at me, I might have to skip it. So we'll start with the flexible and extensible schema. Why is it important to actually be able to easily extend the schema? We talk about the infrastructure graph and the idea of putting everything together. Now, this idea of a source of truth is that you need to have in this system the representation, at least at the technical level, of what you want to automate. So if tomorrow you want to automate a new service, you want to have a load balancers, that means you need to extend your schema. If you're not able to do that, then that's going to be a big issue and you won't be able to actually deliver and support the business. Now, if we go back to those guys that are doing the knowledge graph in the other industry, what are they doing to solve that? And it's interesting to see that they have the exact same requirements. They want to have a graph, they want to have a schema, they value a lot the extensibility of it, they want to have very powerful query engine. And what's interesting to see is pretty much every single implementation of knowledge graph has actually moved to a type of database that we call the graph database. And I personally would love for us to talk more about that, consider the system. I was personally exposed to this database in 2017 when I was working at Abstra. And I remember it was a shock to me. Like, the first time they introduced that, I was like, this is garbage, give me Postgres. I love it so much. And then I realized how wrong I was. Like, it is such a powerful system. And it has much more flexibility into how we can actually build the schema, a very powerful query engine. And again, every single person I know that actually learned those databases fell in love with it. It's as simple as that. And they're actually very mature. They've been around for a lot of years. I cannot find a single reason why we will not use them. So just to give you, again, very high-level overview, like a relational database like Postgres or MySQL is based on a concept of tables. And there's this idea that the schema is defined at the heart of the database. It's kind of really, it's a very impactful actions to modify the schema, which makes it kind of natively incompatible with the idea that we want to have a very extensible schema. Because it means that every time we'll need to make a very impactful action. Where the graph databases, they don't have these constraints. They don't use tables. They have a much more flexible organization of the data. And the schema itself is actually not enforced at the database level. And they have a schema. They have a very powerful query engine. But we just have the same constraint. So there's really no downside of us using that. So that will be the first approach. Now, version control. So important nowadays. Yeah, let me tell you, like, I love Git. Git is awesome. Git is fantastic. Completely changed our lives. We can do branch, we can do diff, we can do merge. It's just fantastic. Now, let's be honest. It is not a database. Like Git, it was initially designed to manage text files. It was designed to manage code. It was never intended to actually be a database. It was never intended to be a system that will understand what is inside the files. All what it sees is lines in a file. How many times when we use infrastructure as code projects did Git find conflicts when there was no conflict? It's just that when you have a YAML file that has thousands of security rules, like what does looks like a security rule, another security rule? Like when you put them next to each other, it gets these conflicts all the time just because it doesn't understand what's in there. And for a long time, that was the only options we had to actually have version control. So I was like, fine, let's use it because there's nothing else. But the good news is there's actually multiple solutions nowadays that are looking at bringing version control and the concept of version control into the world of databases. So we can actually now have proper data, proper schema, a proper query engine, and version control together. And I think it's so critical for us to have version control, but also to have the schema, that our industry, we really need to start moving into that direction. The dry hair is killing me. So I'd just like to highlight one initiative that I was part of when I was at Network to Code, and I think it's really cool. A lot of the reasons why we started Notobot, there was a lot of them, but one of them is that we actually wanted to integrate with Dolt, which is a database that has native support for version control. And that was our attempt to bring more version control into the core of the database. And so, yeah, if you haven't checked it out, go check it out. It's a great initiative and a great project. Now, I'd love to talk about the unified storage and the problem that it solves and why it's super important. So when we looked at the database-first approach earlier, we talked about the challenges of maintaining the system and the fact that every time we have to change the API or we have to upgrade the database, then everything breaks and it's a very complicated process. At the heart of it, it's really because there's such a tightly coupled system between the schema, the data that we have in the database, and the system that are using this data, that are depending on it, like the Jinja templates or any script that will actually consume that data. And if those systems are actually so tightly coupled, maybe we need to start thinking about how we could actually redefine the boundary of what is the source of truth. And to give you a different perspective, if you look at the Git approach, it's a problem that doesn't exist. When everything is in Git, it is actually super easy to manage those complex changes. It is super easy to create a branch, and we can change the schema, we can change the data, we can change the script and the templates, and completely have a very complex change all at once, because everything is into a same unified storage, which happen to be files. Now, I talked earlier, our perspective is that we need to take the data out of Git and put them into a database that has version control. But now we don't want to lose this ability to have this unified storage to manage those very complex changes. So our perspective is that we need to start rethinking the source of truth as not just the database, but actually the database and all the system and the resources that are actually tightly coupled to the internal schema of the database, like the Jinja templates, like the CI pipeline, like the transformation. And when we start extending the boundaries of the source of truth, then now it actually makes it so much easier to manage those transitions. And the idea is really that the source of truth should only expose device-specific language, like configurations or payloads, or things outside, so that it's so much easier. You can refactor internally, you'll have your CI to validate that all the changes fits together, and you don't have to worry about so many of those breaking changes. And really, the role of the deployment should not be to render all of that, should not be to transform or add business logic. It should be just take a config, deploy the config, make it idempotent when you apply, and like it's already a big role. Like there's no need to use all of those tools to actually do the config rendering. I think we've been using them because that's the only options we had, not because it was the best options we had. I mean, I guess if he was the only one, he was the best, but until we can find a different solution. So we are a bit running out of time, so I'm not going to cover too much of the CI/CD pipeline. I hope I'll be able to come back at AutoCon 1 to talk about that. But the point is, kind of Git, like CI/CD pipeline, they've never been designed to manage infrastructure. And the simple fact that they are based on Git, and Git doesn't understand what it stores, and the fact that it can take an hour to just shut down an interface, in my experience, we really need to start thinking of how it would actually look like if we were integrated into a proper database with version control, and that we had a much better understanding of the changes that are going on, and rethink a lot of those concepts. So again, we'll cover that next time, but there's a lot to cover here. So to close, I wanted to give you a vision of what we've been working on and what we think could be a different approach to all of that. So at OpsMill, we're working on what we call the new generation of source of truth. We call it Infra Hub. And the way it works is, at its core, we have this unified storage that has version control. We have a database with version control that can store the data that is tightly integrated with Git, where we can store all the non-data resource, everything that looks like a file, scripts, templates, all of it. Then we have, because we're using a database, a graph database that doesn't have constraints on the schema, we actually can provide full flexibility for the users to provide the schema, change the schema, extend the schema however they want. And then we added the options to render all of those configurations and expose only device-specific language to the outside world. We also added the entire CI pipeline and peer review process. So think of it as like the pull request process you have in GitHub. If we're not using just Git now, we need to have a new system that will integrate the view of the changes we're making on the data and on all the other resources. And then on top of that, we have the UI, the API, and a lot of GraphQL. So the very high level, that's what we've been working on. If we look specifically about the storage engine, so just wanted to touch on how we're actually doing the version control for the data. So we're not using those, we're not using those systems. We actually are using a technique that is used in the graph database called the temporal graph that natively provides this immutable database. So we're able to go back in time, we never lose any state, which just that by itself is pretty cool when you think of running your own infrastructure. But on top of it, we actually extended the concept to make that a multi-layer or multi-dimension temporal graph, so that now we can have branches, we can do diff, we can do merge, and we have all the benefit of version control, but in a fully functional database with a powerful query engine and the ability to really easily extend the schema. So that's what we've been working on. Again, if you want to learn more, come find me. There's a few of us here, more than happy to give you a demo. The project is not publicly available, but the plan is to have it as an open source project at the beginning of the year. If you have any questions?
One good question. Time for one good question.
There's one good question. No one's at the mic. If there's no question, then thank you very much. There's one question.
Hello. How do you recommend organizations migrate from their existing platforms onto some of what you suggest?
I mean, if you already have your data in either in Git or in source of truth, an existing one, your own database or Netbox or Notebook, it's going to be pretty easy to migrate because you already have the data. Most likely you have APIs, so it's just a matter of writing a script and migrating the data. So I will say, yeah, no, I don't necessarily foresee. I think the challenge is when you deploy is like if you don't have anything and you need to extract something from the existing network, that's the bigger challenge. But if the data already exists, we'll find a way to get it in.
Thank you.
Thank you very much.